Hello and welcome to Aerospace Mechanical Lab 1. Today we are going to focus on Lab 5, which talks about aerodynamics and flight mechanics. In this lab we are going to learn about how to fly an aircraft in a flight simulator and then how to actually record aerodynamics data, how to relate the movement of air to forces that act on an aircraft or a car or any object that moves in a fluid. In this lab specifically we are focusing on air. So this lab has two parts. One part is a little less engineering related, learning how to use a flight simulator to fly an aircraft, and the next part is focused on aerodynamics, and that is a bit more engineering related. Okay. In today's lecture, we are going to learn about primary flight controls, which are elevators, ailerons, and rudders. And then we will move on to understanding flight performance. This will be a very short lecture because we don't want to go that deep into aerodynamics, and learning about flying an aircraft needs to be done in a lab itself. Okay. So primary flight controls, we have three different axes, three main axes of movement. The first one is the lateral axis, which is controlled by the elevators, and essentially is in charge of controlling the pitch of an aircraft. This yellow axis you see right here. Elevators are usually located at the back of the aircraft, and these wings, they actually go up and go down and cause the aircraft to go up and go down, the nose of the aircraft to go up and go down. Another axis is called the vertical axis in green. The vertical axis is usually controls the yaw of an aircraft. This yaw is controlled by the rudders, which are two pedals you're going to see in the lab, and moving those pedals is going to move this part of the aircraft specifically, right, which is essentially in charge of the movement in this direction, the left and right movement, the turn movements essentially. This is used extensively on the ground, and there's another type of turning which we call roll that is controlled by ailerons on this axis, so movement on this axis. And ailerons are usually located at these positions on the wing. If you want to turn right, one of these is going to go up, the other one is going to go down. The same is true for turning left. We have a table right here that is going to give you an idea of how each of these movement axes can be controlled using ailerons, rudders, and elevators. I have also included a YouTube video right here. You can definitely click on it and watch it. This goes into a bit more detail about this axis of movement of an aircraft. Okay, let's go a little bit deeper in these flight control mechanisms. The first one we're going to talk about is the elevators. As I said, elevators are right here. Essentially, when you move the elevator up, you're going to create a downward aerodynamic force because of a more concentration of air. Essentially, here that's going to push your elevator down. There's a deeper explanation for this, but we can just accept the more concentration of air on the top. So whenever you see this curvature, that means that there is going to be a force in the opposite direction of the curvature. This is called the camber. So this is a negative camber. Negative camber is going to create a downward force, right? And this downward force right here is going to create an upward force in the nose of the aircraft, right? There we have the center of gravity. When you create a downward force here, the other part is going to go up. So, and if you create a positive camber right here, there will be an upward force that will push the nose of the aircraft down. That is how the elevator works. An elevator is controlled by the yoke of an aircraft. This is what the yoke is essentially. You can pull this towards yourself or push it away from yourself. Aircraft will go up or down based on this control. What ailerons are essentially, I said right here, they are on the wings. If you turn your yoke to the right, your aircraft is going to roll towards right, and if you turn your yoke to left, Your aircraft is going to go left. How does the ailerons generate the lift? It essentially is pretty simple right here. When you're creating a negative camber right here, you see the camber is in the upward direction. This is going to create a negative camber, which means it is going to reduce the lift that is in our desired direction. On the other side, we are going to increase the lift that is in our desired location, right? So we are creating a negative lift here that is going to counteract the lift that is generated by the whole wing. So more force here, a bigger force here, a smaller force here. There will be a roll in this direction, right? And the same is true if you actually create a negative camber here, a positive camber here. We are going to see the reverse effect. Okay. The rudders, as I said, rudders are controlled by pedals. Essentially, if you push the left rudder forward, your rudder right here is going to move to the left, right? Which is going to create an aerodynamic force in the right direction, and your aircraft is going to move left as well. Again, this rudder control is usually used for the ground operation. The reason is with roll, what happens is you are going to lose some altitude, right? And your wings are going to move, right? So you don't want your wings to touch the ground. That's why we use the rudders, but they also are used when you are airborne. Okay, let's look at the aerodynamic forces on an aircraft. We have four main forces that are exerted on an aircraft. We have weight, which is essentially your structural force. We have thrust, which is the force that is generated by your propulsion mechanism. It can be a propeller, it can be a jet engine, or it can be any other type of engine. And we have two aerodynamic forces. Lift, that is essentially in charge of making sure that you keep flying, and drag, that is the negative force that we have, essentially, that is going to push your aircraft back. These two, lift and drag, are the aerodynamic forces that are going to be the focus of this lab. Okay, so let's move on to an airfoil. An airfoil essentially is a cross-section of a wing, right? A two-dimensional cross-section of the wing. We can actually take a look at lift and drag on an airfoil right here. The design target for an airfoil or for an aircraft, aerodynamic design target, is to maximize the lift force, that is the good force for us, divided by the drag force, that is the negative force for us. So we want to maximize this ratio, and this is a variable you're going to read from the flight simulator. Okay. In order to make sure that we can actually use our findings anywhere, we have to non-dimensionalize our lift and drag. How do we do that? By introducing lift coefficient and drag coefficient. So two aerodynamic forces that are our interest is lift and drag. We non-dimensionalize them so we can use the results of a wind tunnel in a real-world application, for example, by introducing lift coefficient and drag coefficient. So essentially the goal of an airfoil design or an aircraft design would be to maximize lift coefficient divided by drag coefficient. Okay. So to study our flight performance, we are going to record lift, drag, or lift coefficient, drag coefficient, or the ratio. We are going to record the angle of attack, which is this angle right here, essentially the angle that the chord line of the airfoil or a wing makes with the incoming wind. This angle is the angle of attack. And then we are going to create a couple of different graphs. One is the lift coefficient versus angle of attack, drag coefficient versus angle of attack, and lift coefficient versus the drag coefficient, or what we call the drag polar. Okay, lift coefficient versus angle. These three are all a performance metric for an aircraft, right? And this is, again, lift coefficient versus the angle of attack is the most important performance metric of an aircraft, and this is the graph I need you to give me in addition to the other graphs, right? The idea is you have a couple of important points on this graph. One is this 0 point. This is where your lift coefficient is 0, and the angle of attack at which the lift coefficient is 0 is an important angle for us. So when you draw this graph, I want you to identify the 0 lift angle of attack for your specific aircraft as well. And then another point is called the stall. This is where you increase the angle of attack so much that the lift generation stops due to flow separation. We don't really need to understand the mechanism, but we need to understand these 2 points are very important points. So essentially the goal in the lab, and I'm going to explain this later as well, is for you to choose an aircraft, any aircraft, and fly it, record this data, CL versus alpha, drag coefficient versus alpha as well, and also drag polar for your original aircraft. Okay, and then we are going to ask you to go to a different software, a CAD software, change a small thing about your aircraft, and then redo this graph, essentially to be able to compare your results. The goal would be to have a sharper line here, essentially a higher slope here, and then a later stall. That would be an optimization of your aircraft. What we are going to change is something that we are going to learn in the recording of the lab itself. Okay, so lab 5, you are going to use a flight simulator. As I said, you're going to use a CAD software that is built in with that flight simulator to change your aircraft, and you're going to compare the flight performance of the 2 different flights, like by drawing the CL versus alpha, CD versus alpha, and the drag polar. The software we're going to use is X-Plane. It is a comprehensive flight simulator. It's a great tool to analyze flight parameters. And we want you to use an aircraft called Cessna 172. Your TAs are going to help you in the lab on how to set this up and how to work with the simulator, how to change one aspect of the aircraft. So make sure to watch the video and make sure to communicate with your TAs in the lab. And the software we're going to use to make modification to our flight is called the Plane Maker. Again, the first step in your lab would be to learn how to fly a Cessna 172, learn how to enable data logging. Your second step would be to modify that Cessna parameters, rerun the flight. And when I say modify, essentially it means that you can increase the length of the wing, or you can increase the angle, this angle of twist of the wing, right? How much your wing goes back or is twisted, or all of these things you can definitely change. In this menu right here, we're going to see a more comprehensive version of this in the lab recording. Okay, and if you want to learn more about the Plane Maker software, how to create an aircraft from scratch, I have a playlist right here, a YouTube playlist that will take you through all of the steps you need to make to create your own flying machine in Flight Simulator. Okay. And you also want to keep in mind that you can install a demo version of X-Plane on your own PC for free, but that's just a demo version. It has limitations. And X-Plane, the full version of X-Plane, is installed on all of the PCs in the Aero Lab. Thank you for listening. Please let me know if you do have a question or concern.